creating this database. Okay. Today will be more of a theoretical discussion, and we are going to see the basic concepts of DBMS, the basic terminologies which we are going to get introduced with today. So, how this database is looks like, how it is modeled, what are the different terms we are going to use, what will be the languages which we are going to operate on with the help of on the database that we are going to see today. Okay, so when I just a minute, I will just present my screen. So when I talk about migrating from a file system to a database management system, it is very clear that I'm not supposed to lose any kind of information or any kind of data which is present in a file system. So what is a file? File is a collection of data, a collection of records. And what is a record? Record is a structured data which is presented. So one record contains some information, and one row in a file is a record. So that record will read information about a particular attribute or particular, sorry, not attribute, particular object in the real world. Say it is a student, so one row is going to talk about completely about one student. That may be containing the roll number, name, address, phone number, marks, percentage, course, class, any kind of data what you are looking for. Okay. And when we try to migrate towards database management system, again we need to take care that yes, no data which is stored in this must be uh, lost. So we will avoid the loss of database, and then only we will be able to successfully utilize DBMS over a file processing system. Okay, so let us try to get introduced with this particular terminologies. So if I am talking about a real world object is called as an entity in the language of DBMS. Entity. What is an entity? Entity is the real world object. Entity is a real world object. But to be very specific about the database entity, we will redefine it as it is a real world object which can be differentiated with the similar kind of object based on its properties. I'll repeat again. An entity is a real world object which can be differentiated or distinguished from similar kind of object by using its properties. So let us say that if I'm telling that there is a student, every student is going to have a roll number, he is going to have a name, he is going to have say marks. So these are the three properties which every student is going to have, right? But roll number for every student will be different. Name for every student will be expected to be different. Marks for every student probably will be different. Okay, so I can say that roll number 1 and roll number 10 are two different entities, but they are of similar type. They are of type student. Both of them have a roll number. Both of them have a name. Both of them have marks. But in that case, roll number for both the students will be different, name for both the students will be different, and probably marks for both the students may be also different. Okay, so that's why one student will be distinguishable or can be differentiated from another student with the help of its property roll number 1, roll number 10, or say name two different students are going to have different names. Sometimes they may have same first name, then surname will be different. Maybe they have same name, at that time roll number will take care of differentiating the students. So entity is a real world object which is defined with the help of some properties, and also those properties help me to distinguish among the similar kind of entities. So I can now say that this is a record of a file which is now tabled, which is now tabled. I can say that 1, 2, 3, 4 roll numbers may be there, names may be there, and marks may be there. Okay. So here, when I say there is a possibility that we have a student number 5 who is also having name A and mark 75. There is a possibility. There is a possibility that say 2 Anand Kumars can be there in the class. Okay, that is possible. So when I talk about this kind of database, here roll number, this student is distinguishable from this student using its properties. What are its properties? These properties are roll number, name, and marks. These properties are called as attributes. These properties are called as attributes. Okay. In DBMS, we call object as an entity and property of that object as an attribute. Okay. So remember these two terms, entity and attributes. So one student can be distinguishable from the other student using its property. The prime property here is roll number, because roll number will be different for every student. That we are sure of it. Even though the student have same name, we are going to have two different roll numbers for the student. In case every student have a distinct name, then even if we are skipping roll number, there is no problem. Name becomes a prime attribute. I cannot distinguish two students using marks because two of the students have same marks. So a student with roll number 70, mark 70, I am going to get two students. But student with roll number 3, I am going to get only one student. Okay. So this way, I am redefining entity as an entity is a real world object which is distinguishable from similar kind of object using its properties. The property of an entity is called as attribute. Okay. These two terms you need to remember because frequently we are going to use these two terms. Okay. Now, if you want to ask anything, you can definitely interrupt in between the class and ask. So entity and attribute, these are the two terms which we are going to take care of. Then we come to modeling of a database. Not database, rather complete DBMS. Modeling. How can we model a database? There are different models. One is called as ER model. Other is relational model. Next is object oriented model. Network model. Hierarchical model. And object relational model. These are the 6 models of DBMS we have. Don't worry, we are not going to learn all the 6. We are just going to concentrate our discussion on these 2 models, ER model and relational model. ER model is also called as, actually elaboration of that is entity relationship model. entity relationship model. Okay, so we are in this complete discussion, we are going to concentrate our discussion only on two models, that is ER model and relational model. Object oriented, network, hierarchical and object relational model are actually the modified models from these existing models. These two models are primarily we are going to see, or primarily they are taken into consideration when the database system is actually designed. So ER model is an entity relationship model, which is a pictorial or diagrammatic representation of a DBMS. That cannot be actually implemented. It is just used at the design level, and we are going to see, we are going to model it diagrammatically and then convert it in any of the other models which are available with us. Okay. So ER model, that is entity relationship model, is a diagrammatic representation, whereas relational model is an actual model which is getting implemented. Many a times you must have used or heard the word RDBMS. RDBMS is Relational Database Management System. Relational database means it is talking about this relational model. Okay, so two models we are going to see. Today we will see them in brief. ER model can be is a separate topic to be discussed, but right now we'll just get introduced towards those concepts. Okay, the ER model and relational model. This is a sample of ER model, sample ER diagram. We have an entity student which has properties student ID or student roll number, student name and student address. Okay, so student has property student ID, student name and student address. College has property college ID and college name. Okay, so this whole is one entity, this is another entity. Okay, the attributes for student are these and attribute for college are these. Fine. So this is a diagrammatic representation of the database which we are trying to consider, where a student is identified with his ID number, name and address, and is studying in a college which is again identified by a college ID and roll number. Okay. Now these are two entities. These are two entities and their attributes. These entities, our basic definition of databases, it is a collection of interrelated data. It is collection of interrelated data. So a student is connected to a college or a student is related to a college. In other words, I can say a student is studying in a college. A student is studying in a college. Right? So we are developing a relationship among these two entities, an association among these two entities. Okay, so a student is related to college or a college is related to student through a relationship called as study in. Are you understanding? Called as study in. So this is your relationship and these two are entities. This is E2 and this is E1. So now E1 student is related or having a relationship with college, which is E2. Fine. That is why this is called as entity relationship model. This is called as entity relationship model. Okay. So this is a diagrammatic representation. Practically, this is not implemented. Okay. So one more diagram we'll see as an example for the same. This is a little bigger one. This is a little bigger picture you are going to get, which has four entities: student, course, subject, and lecturer. See, this diagram This model of database gives me every information about that database. What are the entities in that, which entity is related to which other entity, what are the attributes of every entity, what will be the keys of that entity, what will be the prime attribute of that entity, and all. It is going to tell me everything, every detail about that database. Okay, so that's why it is called as a model of that database, and it is a diagrammatic or pictorial model, pictorial representation of the database which we are trying to work on. Try to understand the many very simple things which right now I am going to tell you. Here I am having 4 different entities: a student, course, lecturer, and subjects. These are 4 different real world objects which are in existence and take part in the we can say a database of a school or college or a training institute. Okay, so here I am going to relate. A student is taking admission for a course, he is learning some subject, and a teacher is teaching that those subject. That scenario I'm trying to make a picture of or model it through a ER diagram. So now we will see the details one by one. A student has properties. Student has properties. He has student name. He has student ID, student name, age, hobby, date of birth, his address, and the course which he is taking. Okay. So what a student is having? Student having all these attributes. Now you can mark, you can observe the difference. What difference you are observing in the attributes which are presented for a student? What are the different observations in this? A student is having several attributes. These attributes are represented in the elliptical blocks. So, but are they different? What difference you can find in all of them?
The hobby is having two ellipses representing it, and age is having a dotted ellipse.
Right, right. Good observation. So, hobby is having 2 ellipses, whereas your age is having a dotted ellipse, and also one thing you can mark is student ID is underlined here. Okay, these are the 3 things which we can observe. Few more things which one more thing which you may be observing. Anyone else? Sakshi has already answered.
So the address attribute has more than as a sub attributes.
Pardon, please repeat.
Student has an attribute called address, which further
Ah,
has attributes called door, street, and city, state, pin.
right. So student has address, and that address has further attributes you can observe. Now, as I said, DBM, this diagram is going to tell me everything about that whole database, how it is implemented, how the things are managed. Okay. Let us now observe one thing, that the course has course ID and course name, lecturer has lecturer ID, like subject ID and subject name. Subjects have lecturer ID, uh, subject ID and subject name, and lecturer has lecturer ID, lecturer name, and course ID. Now you can observe one thing is that every attribute has one attribute, every entity has one attribute which is underlined. Okay, so which is underlined? These underlined attributes are the primary attributes or prime attributes or primary keys of that student, of that entity. What do you mean by a primary key? That is the unique attribute which is not going to get repeated. As we seen in the previous example, name may be repeated for a student. Thus, two students may have a same name, but their ID will always be unique. The way you are getting your UID in the college you have, that ID will always be unique for every student. It won't be repeated. There is a possibility that name get repeated. Two lecturers may be there of the same name. Probably the course may have a same name, but course ID will be different. Okay. So every attribute has, every entity has one attribute which is underlined, and that is a prime attribute or primary key of that particular entity. Second thing is, here I can observe student name, course ID, and DOB are the other attributes which are present. Okay, are the other attributes which are there. So student can have a unique name, or the name, there is a possibility that two students in rare cases have same name. In many cases, it is possible that two student or three student or four student may have a same date of birth. It is possible. And yes, many students are taking same course. That is also possible. Okay, many students are taking same course. That is also possible. So this course ID is taken from this course. Now we have an address. You have an address which is now further have several smaller attributes. Okay, address can be either written in a single string, or I can have door numbers separately, street name separately, city name, state name, and PIN number separately. You generally go on, you fill in several forms for several exams or reservations and all. There, in few cases, you will find that address is going to have only one block, and you write the address the way you want. And in some cases, you are going to have like plot number or door number, street, locality, city, state, PIN number, country. That is a separate field every time. Okay, so there are we can have address as a single attribute or a single string, single set of characters, or we can have group of attributes amalgamated together to form an address. So here in this case, it is happening. Here it is happening. Okay, this address is a collection of different smaller attributes. Thus, it makes this attribute as a composite attribute. I make this attribute as a composite attribute. Fine. Again, I am repeating. Student is a primary attribute. Student name, DOB, course ID are the other attributes, normal single valued attributes, whereas address is a composite attribute which is not directly having its own value, but it is taking values from other sub attributes it has. Okay, these are the sub attributes it has, and it is amalgamated, it is brought together to form the whole address. Okay, so this is called as a composite attribute. Next thing is you find age with a dotted ellipse. Dotted ellipse, if you have, it is called as a derived attribute. It is called as a derived attribute. Derived means it is taking help of some other attribute to generate its value, to derive its value. Because if you are taking admission in first year, your date of birth is going to be noted. You may be of age 18 that time, but if your age is accessed after one year, it should change to 19. Okay, that's why we make age as a derived attribute, and it will take help of DOB, and that value will be generated whenever it will be accessed. Okay, that is called as a derived attribute. Fine. And double line attribute is actually multi-valued attribute. Or a weak attribute. Multi-valued means you may have more than one hobbies. You may have more than one phone numbers. You may have more than one siblings, more than one brothers or more than one sisters. So the attribute which can hold more than one values is called as a multi-valued attribute, and it is represented in a double line ellipse. So are you observing that only this diagram can give me every information about that database? Coming back to this again, course is defined with course ID, course name. Lecture is defined with course ID, course name, and lecturer name and course ID. Whereas subject is defined with subject ID as a primary key, lecturer ID, and subject name. Now, what can you observe is the primary key of lecturer, that is lecturer ID, is appearing here also. Our primary key of course is appearing in lecturer as well as in student. This is possibility. Okay, you can have a primary key of one entity as the attribute of other entity, and that is called as foreign key. That is called as foreign key. We'll right now just you remember this. We'll come to that later. This is called as foreign. Right. So every attribute, every entity can have normal attributes, can have is actually expected to have a primary key, may have a derived attribute, may have a composite attribute, may have a multi-valued attribute, but my diagram should be able to tell me everything about that. Okay, I'll just clear these things. Now again we'll see the diagram. Now there are four entities, and these four entities are related to each other. They are forming relationship among each other. They are forming relationship among each other. Okay, it is not necessary that every entity will be connected to all the other entities present in that database. Okay, but we will avoid any entity which is not having any association with any of the other entities in the database. Okay, we cannot have a single entity which is not connected to any of the entities, which is not, it is not a good part to or it is not a good component to participate in the database management system. So you need to take care that every entity must be associated with at least one entity in the database. It can get connected with more than one entities also, but it is even not necessary that every entity should be connected to all the entities in the database. Okay, so now you have observed that the entities are posted in a rectangular block. Attributes are posted in a elliptical block, and similarly the relationships are posted in a diamond block. Okay, so a student attends a course. Student attends a course. So attends is a relationship between student and course. Course has subjects. So it's an association between course and subject. Lecturer teaches subject. Lecturer teaches subject. Okay, this is the association between lecturer and subject. A lecturer teaches student. Association between lecturer and student. So and lecturer takes course. lecturer takes course, this is also association between lecturer and course. So you can find that lecturer is connected to all the other three entities. It is connected to student, it is connected to course, as well as it is connected to subject. Whereas course is connected to student and subject. Course is also connected to all the three. Student is connected to course and lecturer only. It is not connected to subject, but it is getting that connection through course. If he is taking this course, he is going to learn those subjects. Fine. So a student attends course. Course has subject. That is why the student learns this subject. So lecturer teaches a student. He also, so he is teaching a course. Why is lecturer is teaching a course? Because student has taken that course. If the student has not taken, if you are not there in computer engineering, I won't be teaching you any subject. I am not teaching it to the mechanical department or etc. department. Okay, so that association also gets built up because of some facts. When the student course takes that respective course, then only the student will be taught by that particular lecture. Okay, so these are the things which are observed. So here again I am repeating, in the ER model, entities are posted in a rectangular block, attributes are posted in the oval blocks or elliptical blocks, and the relationship is posted in a diamond block. To repeat, primary keys are underlined, derived attributes have a dotted ellipse, multivalued attributes has a double line block, and there is a possibility of composite attributes also, which doesn't have its own value, it takes the value from its sub attributes. Also, the primary key of one entity can take part or become an attribute of another entity. That time it will be called as a foreign key. Okay. Now, what's remaining? Now, what's remaining in this?
Small characters MN1.
Yes. Characters M, N, and 1. Okay. These are the things which are left. So this is called as mapping cardinalities or mapping constraints of a ER model. That means these constraints are one to one, one to many, many to one, and many to many. Means one student, if I am saying that MN here, that means many student can take many courses. Many student can take many courses. If you are going to an institute, you can attend 2 or 3 courses. So there is a possibility of many students taking many courses. That's why M and N are holding some value other than 0 and 1. Okay. One course may have many subjects. One course have many subjects. Many subject may belong to only one course. So one to many. This is many to many. One to many. Okay. One lecturer teaches only one subject. One to one. One to one. Many lecturers may teach one student. As you are one entity, many teachers are coming and teaching you different subjects. So many to one, one to one, one to many, and many to many. Here also, a lecturer may take many courses. Okay. So this 1, M, and all are representing the mapping cardinalities, means one row from student may be connected to many rows in the course, or many rows from student may be connected to one course. So many to many. Many lecturers may teach only one student, many to one. One lecturer teach only one subject, one to one. Okay, so this way your ER diagram actually completely describes the model of a database. I understand it. So this diagram can be much bigger. This diagram can be much bigger. More number of attributes, more the relation, more number of entities, more the relationships will be, more the relationships, more the attributes, more complicated will be the diagram. But we should take care that the diagram should be drawn in such a way that it will accomplish or it will represent the complete design of the database. Are you getting me? So this is your ER model. Again, I am repeating, it is a pictorial representation of the whole database management system. It has entities, it has attributes, it has relationships. It has relationships. And one thing I forgot to tell, this relationship also has attributes. These relationships also has attributes, but what happens, what will be the attributes it has? It will have primary key of both participating entities as the attributes. Means if student and course are participating in this relationship, attendance is going to have by default primary key of student and primary key of course as its attribute. So course ID and student ID will be the default attributes of attendance. Similarly, has relationship will have course ID and subject ID as the compulsory or default attributes of the relationship. Okay, along with that, it can has its own attributes. Like here, if I'm talking about a lecturer is teaching a student. If I'm saying that a lecturer is teaching a student, so student ID and lecturer ID will be default attributes. And along with that, I can have, let us say, the time. At what time he is teaching him can be an additional attribute that relationship can have. Okay, so relationship can have its own attributes, but if its default attributes are always the primary key of the participating entities, right? And this example is giving you that relationship as binary, means two entities are participating in the relationship. We can have tertiary or 4, 5, n number of relations, n number of entities connected together to form a single relationship. Okay, so that is also possible. This is these are the two diagrams of ER model we have seen. This is a small one, and this is quite elaborative one. Still, bigger diagrams can also be managed. So this is about ER model. The next model is relational model that we'll see in the next lecture. Today we'll stop here. Anything you wish to ask?
Sir, why lecturer ID and lecturer name mentioned in bold font?
No, that is just that is it happened. वैसा कुछ नहीं है उसका identification नहीं है. So making anything bold is not suggesting anything in ER diagram. वो गलती से हो गया समझो. Anything else? And if you don't have anything to ask, you can leave. If you want to ask something, you can stay back and ask.